Welcome to the DEAS project, part of the FLUIDOS first open call, where we explore dynamic workload offloading based on 5G channel quality. In this demonstration, we show how FLUIDOS enables smart and efficient workload distribution between a drone and an edge server using 5G metrics. Let's dive in and see how it works. Let's start watching the FLUIDOS Dashboard, developed for the DEAS project. At the moment, the drone device is not connected to the edge server and presents an offloaded namespace. Now we wait for the creation of the resources that manage the peering lifecycle in FLUIDOS. These terminals are watching a set of resources on the drone node. In the top left corner terminal, we can see that a known cluster resource has already been created by the FLUIDOS discovery agent. Now looking at the terminal in the top right corner, we can see that a solver has been created. Its status is completed. This means that FLUIDOS was able to find a cluster which satisfy the resources and requirements requested by the solver. Finally, in the bottom left terminal, we can see that a new node called LICO Edge has been created. This means that FLUIDOS was able to create the peering successfully. We can also use the FLUIDOS dashboard to check the peering status, as you can see. Here we are able to have a more user-friendly view of the status of the peerings. Now it's time to focus on the dynamic offloading based on 5G metrics. In our demo, the drone and the edge server are linked using a 5G channel. The objective is to keep the workload on the edge until the connection between the two entities is good and move it to the drone if the connection is going to be lost. To achieve this, we rely on a score about the quality of the connection retrieved from the 5G cell. The red and blue lines in the graph show two thresholds. When the score is above the higher threshold, the workload will be executed on the edge. Otherwise, if it is below the lower threshold, it will run on the drone. In the terminal, you can see a pod running in an offloaded namespace. Let's look at the node where it is scheduled to understand if it is running on the drone or on the edge. At the moment, it is running on the drone, but we will see it moving on the edge when the signal quality increases. As you can see, the pod just moved to the edge. Now, let's wait for a signal degradation. In order to achieve this, we moved the drone in another room. The score has just moved below the lower threshold, and it has dynamically rescheduled on the drone as expected. This ends our demo. Thank you for your time and interest. If you have any questions or would like to continue the conversation, feel free to reach out.